we are going to see some assembly language code snippets of 8051 programming. So this is a very common type of question we generally see in competitive examinations. That is, some code snippet will be given to you, and after execution of this code snippet, you need to find what is the result coming from the given options. Okay, so this type of questions I have not seen in any particular video. So I thought of doing this for all the people who is preparing for this competitive examination, especially for GATE, ISRO examinations, BARC examinations. This type of questions is very important, especially for assembly language coding. Okay, so the question will look like this. That is some code snippet, especially addition or 8051 programming or 8085 programming. In this type of assembly language code snippets will be given to you. You need to find what is the result after the execution. Okay, so that is a question. Okay, let us see what is the first question. How are the status of carry, auxiliary carry and parity flag affected by the instructions? Okay, what is the instruction? Move a comma hash 9c, then add a comma hash 64. That is, this is a very simple instruction or two-step instructions in which first 9c is moved to a, then adding a with hash 64. That is, first you are moving the value 9c to a, then you are adding a, that is 9c is present in a plus 64. Okay, hash means it is an immediate value. Okay, so you should be knowing the very basic programming things to answer these type of questions. Hash means immediate value, that is, it is a number directly being moved to that register, and then this number is directly being added with the content of the accumulator. Okay, so we will, while discussing these type of questions, you will also get familiarized with these very basic things. Okay, so what is the result of this instruction? That is not the question actually. You need to find the status of carry, auxiliary carry and parity flags. These flags are present in which register or 8051? There is a register called PSW, that is Program Status Word Register, where this carry, auxiliary carry and parity flags are present. You need to find what is the value, whether 0 or 1, what is the value getting stored into these flags after this instruction is getting executed. Okay, so this is nothing but the addition of 9c and 64, because first 9c is moved to a, then a is added with 64 means 9c is added with 64. Okay, I'll perform the addition here. 9, you have to write the BCD equivalent of these two numbers to perform the addition. For 9, you get the addition of these two numbers. You actually have to write the BCD representation for 9C64, and then you have to add the corresponding nibbles. Okay, so that is what we do for addition of these numbers. These numbers are given in hex value. So I'm going to write the BCD for 9. It will be 0 1 0 0. It is 1 0 0 1 for 9. Then for C it is 1 1 0 0. For 6 it is 0 1 1 0. Then 4 0 1 0 0. Now I'm going to add these two numbers. 0 0 0 carry 1. So 0 carry 1 0. Then again 0. Then again 0. Then again 0 carry 1. So this will be the result of the addition of 9c and 64. Now the result is actually 0 0 0. Or this nibble and this nibble is 0. But there is a carry 1 here. Okay. So the result is actually completely 0 with a carry 1. So the carry flag has to be 1 since a carry is generated. Okay. So first thing we got that the carry flag is 1. Then we have to look for the auxiliary carry. In order to see for auxiliary carry, we have to see whether there is any carry generated from the D3 bit to D4 bit. That is how we check for auxiliary carry, AC. Auxiliary carry means whether there is any carry generated from the D3 bit to D4. That is 0, 1, 2, 3. This is the D3 bit. From this bit, whether any carry is generated to D4 bit. Yes, there is a carry generated from this bit to this position. So the auxiliary carry is also 1. Okay. So when there is a carry generated from D3 to D4, auxiliary carry is set as 1. So we have got carry is 1, auxiliary carry is also 1. Now how to check whether parity is 0 or 1? Parity means the number of ones present in any number or any result. Here we have to check the number of ones in the result. If the number of ones is odd, then the parity is 1. If the number of ones present is even or 0, then the parity is 0. Okay, so here this is the result. This one is a carry. So for the result, all bits are 0 and there is no ones. So the parity flag is equal to 0. Consider if there is a single 1 present. I am just taking an example. If there is a 1 present, means parity number of ones is only 1 and 1 is a odd number. So if the number of ones in the result is 1, parity is 1. If the number of ones in the result is odd, then the parity is 0. Okay, so here all numbers are 0. There is no 1, so the parity is 0. So the status of carry, auxiliary carry and parity will be carry is equal to 1, auxiliary carry is equal to 1 and parity is equal to 0. I hope these three conditions, how to check these three conditions is clear to you. Carry means whether there is any carry. Yes. So carry is 1. Auxiliary carry means D3 to D4 is any number or any carry generated. Yes. So auxiliary carry 1. Parity means number of ones in the result. If it is odd, parity flag is 1. Here the number of ones, there is no ones. So parity flag is 0. Or if the number of ones is even also, we have to take parity as 0. Okay, so this is the status. Now moving on to the next question. A valid division always make dash. Carry 0, auxiliary carry 1. B, carry 0, auxiliary carry 0. C, carry 1, auxiliary carry 0. The correct answer is B. A valid division always make carry as 0 and auxiliary carry is equal to 0. So whenever a valid division is happening, consider that 4 by 2 or a valid division is happening means carry and auxiliary carry is always made as 0. Find the number of times the loop is executed. Okay, let's see what is this code snippet. Move R6, hash 200 means the number 200 is stored to register R6. Then back move R5 hash 100 means the number 100 is stored to register R5. Then in this statement or in this instruction, here is actually a label. DJ NZ means decrement and jump if non-zero. R5 100. Sorry, here. So here this statement will execute how many times? It will execute 100 times because the value 100 is present in register R5 and it is decremented every time, and till the 100th time the value of R5 is not 0. That is, it will start from 100, then 99, 98, 97. Likewise, this loop will execute actually 100 times till the value is 0. Okay, so when the moment the value is 0, it will jump out of the loop and it will reach here. Okay, so this statement has to execute repeatedly 100 times because the register R5 is having value 100. Next statement, DJ NZ R6 back. So this back label is actually present here. So this statement or this instruction will decrement the value present in R6. And what value is present in R6? 200 is present in R6, right? So this will decrement the value of R6. That is, from first time it will be 200, then it will execute once and then it will go back here. Again it will execute this statement, then again it will be 199, then again it will come here, it will execute this statement and then 198. Likewise, this loop will go on how many times? 200 times this loop will execute. Then after the value of R6 is, that is, the moment the value of R6 is 0, it will end. So how many times this loop will actually execute? It will execute 200 into 100 times. Okay, I'll explain once again. See, this statement is actually executing 100 times. And this statement or this loop or this loop or decrementation or this statement is present again inside a loop which will execute 200 times. Okay, so this outer loop will execute 200 times, and every time this outer loop is executing, this DJ set or this statement is executing 100 times. So total execution time is 100 into this outer loop 200. I hope this figure is making it clear. This outer loop executes 200 times into inner loop executing. Every time the outer loop is executing, the inner loop is 100 times executing. So 200 into 100 times this total execution will happen. That is, this total loop will execute 200 into 100 times, which is 20,000 times. Okay, the number of execution is 20,000. Correct answer is 20,000. The options can be 2,000, 200, 100. It can vary. Anyway, you have to pick 200 into 100. Okay. Next question. JZ, JNZ, DJNZ, JC, JNC. I hope that if you have done these type of assembly language coding in your laboratories of microprocessor or microcontroller lab. So these are basic things. Okay. JZ is JEMBIF 0. JNZ is JEMBIF non-zero. DJNZ means decrement and JEMBIF non-zero. Here all we are using DJNZ. It decrements and then checks whether the value is 0 or not. Then JC means JEMBIF carry. JNC means JEMBIF not carry. It checks whether a carry is generated or it checks whether the carry is 0. Okay. So these instructions monitor the bits of which register? These instructions actually are present in the PSW register. These flags, that is carry flag, 0 flag, auxiliary carry, all these flags are actually present in the program status word register. So these instructions monitors PSW register for its execution. Okay, correct answer is PSW. Various options will be given: accumulator, B register, DPTR, all these can be options. But the correct answer is program status word is being monitored when these instructions are encountered. What is the meaning of instruction move A, 05H? Okay, so move, I'll write the instruction once again, 05H. What is the meaning of this instruction? Here 05H, whether it is a data or an address, you have to figure out that. This is actually an address, and this address is stored to accumulator. A is accumulator register. So 05 is actually a address. Now how to figure out whether it is an address or not? If it was a data, then you have to represent it using hash 05H. This hash indicates that this is a data. If a hash is not present, means this is an address, and this address is actually getting stored to the accumulator register. If it was a data, always this immediate values or datas is associated with a hash. In the previous questions also, while adding or while moving of immediate data means a number. That number is for some operations we are moving to accumulator. So if it was a number or if it was a data, then it is associated with a hash. Always you have to check for this hash to find out. Okay, so this is our address, and the meaning is you are moving 05H, which is an address, to the accumulator register. Okay, moving on to the next question. The content of A register after the operation is executed. Okay, move A hash 0BH. So you are moving, see here, this is a hash. So this is a data. So this data is moved to A register. Then ANL A comma hash 2CH. This ANL indicates logical AND operation. Okay, so you should be knowing this logical AND or XOR. This logical AND is represented in assembly language coding using ANL. Okay, so in the next step or in this next instruction, we are taking the logical AND of the value present in A with hash 2C. Again, this is a data. So with 2C, you are actually doing the logical AND operation of A, the value present in A, which is nothing but 0B. So I have represented the BCD for 0B and 2C. This is the value, and you have to take the logical AND of these two numbers. This is 0B and this is 2C. Okay. And I'm going to take the logical AND operation. What will be the value? 1 and 0 logical AND if you take, and if it is 1 and 0, result is 0. Again 1 and 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0. So this will be the value or the result of the logical AND operation, and this value is actually getting stored to the accumulator register. You know that whenever an addition or any mathematical or arithmetical operation is performed, the result is getting stored to the accumulator register. So if you are performing this arithmetical operation or this instruction is getting executed, the result will get stored to accumulator. So this thing also you should know. When a arithmetical or a logical operation is performed in 8051, then the result is getting stored to the accumulator register. Next question. I'll remove this to make some space. Okay. So my aim while doing this video is to make you just familiarize with some coding executions and some basic things, so that it should be easy for you if you encounter these type of questions. Okay. Move A, at R1 will dash. Actually, what is the meaning of this instruction? Okay, I'll explain. There is a register here and there is some memory. This is some memory and the memory has an address, and this address is actually present in your register R1. Okay, so this is the instruction move A, at R1. I hope that this figure explains everything. You are moving the data from this memory location to accumulator register, and it is a register indirect addressing mode. Okay, so this in this addressing mode is called register indirect addressing mode. You are actually moving the content of a memory to accumulator, and the address of this memory location is present in the register R1. So this is explained with this instruction. Move A, at R1 means R1 is having some address, and the address, this address is actually the address of a memory location. From this memory location, some data, here some data is present. Okay, this data you actually want to move to A. Okay, I hope it is clear. Please note this figure and this instruction. Okay, so this data you want to move to A, not this R1 or this address. You want to move this data, but you are not directly mentioning this memory. You are actually mentioning the memory with the help of R1, and R1 is actually holding the address of this memory location. Okay, is this a valid statement? Set B A. What is set B? Set B means set bit. That is, this instruction is used to make any particular bit 1. But if you take this A register, A means it is an accumulator register. Accumulator register is having how many bits? 1, 2, 3, 4, 5, 6, 7. It has 8 bits. Okay, so totally 8 bits are present in accumulator register. So if you are giving such an instruction to accumulator, means it is a false instruction or this is a wrong instruction. Set B can only be used with a particular bit. For example, set B P0.1 means from the register P0 or from the port P0. P0 is actually a port. So from port P0, the first bit is set as 1. A port is having 8 pins or 8 bit, or consider any other registers is used, or PSW.2. Okay, means this second bit of PSW is set as 1 for set B instruction. So set B means set bit. It is only used with a particular bit, not with an entire register. If you use a register here, it means that you are using the entire register and it will be confusing. You don't specifically write here what is the particular bit you want to set. So if you use an entire register, it is a wrong instruction. You have to specifically write which bit you want to set. So this is a wrong instruction. Next question. This program is executed continuously, A true, B false. Let's see the instruction or the code snippet. Start, which is a label. move A hash 01 J jembif non-zero stat. Yes, this instruction will get executed continuously because in this instruction you are only moving 01, that is 1 is being transferred to A, and you are jembif non-zero, that is you are checking whether the accumulator is 0 or not. You are checking whether it is getting 0 or not. That is 0 will not be set. Jane said is actually checking PSW register. But PSW, in this PSW there is a field called 0, and that 0 field is set only when the accumulator is loaded with a 0. Okay. But this will not make accumulator 0. Why it won't make? Because you are only transferring a 1 to accumulator, right? While executing this instruction, the only thing you are doing is moving of 1 to accumulator. You are not decrementing or reducing any values from 0. So there is no chance of accumulator getting 0. So there is no chance of 0 field in PSW register to be 0. That is, it won't get set. The 0 field is not getting set. So this loop will actually execute continuously. And in this loop, the only thing is, which is being done is moving of 1 repeatedly to A. Okay. So, in this, you are only moving 1 to A, and this will execute continuously. The correct answer is true is the correct answer. Okay. This type of some small confusing little code snippets will be given to you for the competitive examinations. Okay. So, please do these type of questions from various sites or over the internet. You can find varying questions. Okay. Next question. If sub means subtracting, A, R4 is executed, dash is done. Actually, what has been done while this instruction is executed? A, R4 plus A, no. This is not a addition. This is a subtraction. R4 minus A, no. A minus R4, it is a correct answer. R4 plus A also not wrong. That is, I'll write it here. Sub A, R4 means you are reducing or you are subtracting the value R4 from A. That is, there is a A and you are subtracting minus R4. This is actually executed while this instruction is performed. Okay. A minus R4 is performed. Sub A, R4 means subtracting R4 from A, not A from R4 or addition. It is subtracting of R4, that is second register or value, from the first one. Okay, so this is actually performed. The correct answer is option C is the correct answer. So these are some questions which I have included in this video. These type of code snippets, if you practice, it is very useful for you. So these are the questions which I have included in this video. I hope that this video was useful for your preparation, because I have not really seen any videos explaining about these assembly codings or assembly coding type of problems, that is giving of code snippets and finding the answer from the options. So I really hope that this will be useful for your preparations for any competitive examinations of electronics. So if yes, please do give it a thumbs up and also share this video with maximum of friends. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.